Okay, so we've talked about a lot of stuff. I don't even know where to begin with this, right? So we've talked about reactions between sodium hydroxide and hydrochloric acid, standardization of hydrochloric acid, the antacid adding into the flask, swamping that flask with extra acid so we have some stuff left over, and then titrating that acid to figure out how much is left over, and then taking the difference between those two numbers to figure out how much acid was actually used up. All right, so that's where we're going to start this video. In the previous one, we said that we had 0.000179 moles of acid that was used up in the experiment. Okay, so now I need to figure out what to do with that in regards to the antacid concentration. Okay, so let me erase this up here. And it looks like I got a little eraser happy here. So we'll do CaCO3. We'll write that back in. And now I need to figure out how this relates to the amount of antacid that I have in my tablet. Okay, so 0.000179 moles of acid was used up. So this is how many moles it took to neutralize my calcium carbonate. So I'm going to set up a dimensional analysis problem here. 0.00179 moles of HCl over 1. Mole of HCl on top, mole of HCl on the bottom. I need to convert that over to moles of CaCO3. Up in the reaction, the balanced chemical equation, here's my hydrochloric acid. There's a 2 in front, so a 2 goes here. And my CaCO3 has a 1 in front, so a 1 goes there. So in order to calculate the moles of calcium carbonate, well, I just take 0.000179 and divide it by 2. But you know, that's not where we want to stop. Where I want to stop is milligram, because that's how it's going to be on the actual label. I want to calculate milligrams of calcium carbonate here. So I'm going to chain on another dimensional analysis step. Mole of calcium carbonate, so mole of CaCO3 goes here, and I need to convert that over to gram of CaCO3. Now this is formula weight. And you know, I'm not going to do that for you. I want you to calculate your own formula weight or to find the formula weight. But this is where the formula weight's going to go. It tells you this is how many grams there are in 1 mole. So in the next step, gram of calcium carbonate on top, gram of calcium carbonate on the bottom. I need to get to milligram. So 1,000 milligrams is into a gram. And this will give me milligrams of CaCO3. And hopefully, this milligram will be the same milligram as there were in my tablet. So in a nutshell, that is the math that you will have to go through in order to get the milligrams of calcium carbonate in your sample. Quite a bit of stuff, right? So I've got moles of hydrochloric that was used up. I take half of that number based on the stoichiometry. That gives me moles of calcium carbonate that was there. Use formula weight to convert that over to grams of calcium carbonate. And then I'm going to multiply that by 1,000 to get the milligrams of calcium carbonate. Now, if you don't use the whole tablet, what happens? What if a whole tablet was not used? Well, we know the number of milligrams per tablet. And we can do an average tablet weight here. So what we would do is that we would take a handful of antacid tablets and we would weigh them. do an average, and report the average tablet weight. The label itself says, this is how many milligrams there is in a tablet. So we average that weight out. Well, you know how many milligrams that you've gotten based on your calculation. And you know how much weight that you started with as far as the antacid goes from the very beginning. You weighed this out. You weighed it, or you massed it. This was my original number right here. So, if I want to relate this to a tablet, what I would do is that I would pretend like I didn't know how many milligrams there was in a tablet. And I know all the other numbers that I need to in order to solve for that answer. So I don't know how many milligrams should be in a tablet, so I put that as X. I take the average tablet weight. If you need this, it will be written on the board for you. We will go ahead and take a handful of tablets and weigh them out and do an average. We'll tell you how many we averaged up. That is a number that I know that goes into the system. I know the milligrams of calcium carbonate that I solved from this reaction, right? Maybe I didn't use the whole tablet, so I'm not going to get the whole entire milligrams that's printed on the label. I need a ratio and proportion this out. So that's the number of milligrams that I've got from this amount of antacid that I weighed out from the very beginning. So I just cross multiply and solve for X. And hopefully this number matches the label. And that is what we have to go through to label validate the antacid tablet. Who would have ever thought it was that complicated? Who would have ever thought that that much math was going to be involved in this lab? But that's what we do. So, you're going to standardize the HCl, and you need 3 samples. You're going to titrate your antacid, and that requires 3 samples. And then you're going to titrate this using the titrando, and you're going to do another 3 samples. Your antacid by hand and your titrando by hand, you will average those up and report the milligrams of CaCO3 that you have found. You'll relate that to the label through the ratio and proportion step. And hopefully you'll get a number that is close. All right. So that's it of the math. In the next video, we'll take a look at the spreadsheet and we'll talk about what we want from the spreadsheet. So stay tuned, especially if you're uncomfortable with Excel.